Hello everyone, Elliot Severn here with the Discovery Museum's Henry B. DuPont III Planetarium, and this week we are going to go on a tour of the outer solar system. And to start our tour, we are going to fly to the planet Uranus. And here we are at Uranus. It's the first of the icy giant planets. It's much larger than Earth, but it's much smaller than the gas giant planets Jupiter and Saturn. It has an extensive ring system similar to Saturn's, and it's this deep bluish-green color. And the reason for that is the ammonia and methane in its atmosphere. An interesting thing about Uranus is how it rotates. Compared to the other planets, its axis is tilted on its side. And so as it spins around, it often has one side pointed to the sun for long periods of time, and one side of it is sometimes pointed away from the sun for years and years. Uranus is the first planet to be discovered through a telescope in modern times. It was discovered by William Herschel in 1781. And this is the telescope that he discovered it through. Uranus has only been visited by one spacecraft. In 1986, the Voyager 2 mission flew by Uranus. It has not been visited by any other spacecraft, and we have not yet had an orbiter around any of the outer planets. Uranus's rings are split into many different sections. However, they are very thin. Most of them are no more than a few kilometers wide. And there are some small moons in between the sections of its ring system. We're going to travel to one of its more interesting moons now, which is Miranda. And here we are at Miranda. It's a very small moon. In fact, it's the smallest known moon that can keep a spherical shape. In the images from Voyager 2, we saw that Miranda almost looks like it's split into three sections. Originally, we thought that it had broken apart in a giant impact and reformed afterwards. Our current theory is that warmer ice in the interior tries to rise to the surface, causing these features that we see. And now we're going to head off to the next icy giant planet, which is the planet Neptune. And here we are at Neptune. it is the furthest icy giant planet from the Sun. It's named after the god of the ocean, and that's because of its deep blue color. It's about the same size as Uranus, and when Voyager 2 flew by it, it had a storm on it called the Great Blue Spot, kind of similar to Jupiter's Great Red Spot, but a bit smaller. It has a ring system similar to Saturn and Uranus, but its axis has more of a regular tilt. It doesn't spin on its side like Uranus does. Although its Great Blue Spot isn't still there today, our ground-based telescopes are able to see various storms that develop on its surface. And Neptune has many moons, smaller than those of the gas giant planets. However, it has one large moon called Triton. And here we are at Triton. It's the largest moon of Neptune, and as you can see, it's almost as large as the Earth's moon. It's very far out away from the sun, which makes it very cold, and so there are interesting features on Triton which we don't see in many places in the solar system. As Voyager 2 flew by it, it made a close approach and snapped these high-resolution images of its surface. And it saw many interesting geological features, including things like cryovolcanoes, which shoot out water instead of magma, and geysers, which shoot out liquid nitrogen onto its surface. And Voyager 2 also discovered that its icy surface does evaporate some, creating a tenuous atmosphere that surrounds its surface. And here's an artist's impression of what that haze would look like over the surface of Triton. Alright, we're gonna leave the Neptune system now and fly to the next object in the solar system, which is Pluto. And here we are at Pluto. It's the largest object in a zone of icy objects known as the Kuiper belt. It's a very small world, about the size of the country of Brazil, and it has many interesting features on it. It was discovered in 1930 by Clyde Tombaugh, who discovered it through a 13-inch telescope. He discovered Pluto by surveying the night sky, and he would take images of a field of stars on 2 separate nights. Afterwards, he would compare the 2 images and see if any points of light in the field moved positions over time. If they moved positions over time, it means that it wasn't a star. It was an object orbiting the sun in the solar system. And in January of 1930, he discovered Pluto, and it was a huge discovery. It was the 9th planet in the solar system. And for decades, it remained the 9th and final planet in the solar system. Eventually, though, we discovered more objects in the Kuiper belt. We're going to talk about those in a few minutes. Now, until recently, nobody knew what Pluto looked like. Even through the Hubble Space Telescope, it was only a few pixels across. And so we knew how far it orbited from the sun, and we knew how large we thought it was, but we didn't know what it looked like until we sent the New Horizons spacecraft there. A small spacecraft about the size of a baby grand piano, it was launched on an Atlas V rocket in 2006, and at the time it was the fastest man-made object ever launched into space. Even at that high speed, though, it took 9 years just to get to Pluto, and it flew by in the year 2015. And these are the images it returned. It revealed a dynamic world covered in ice. It has mountains about as high as the Alps. It has glaciers which flow across its surface. It even snows on Pluto, and we believe it has cryovolcanoes. And as New Horizons passed behind Pluto, it saw a hazy atmosphere surrounding the planet, a layered atmosphere similar to what we see here on Earth. And Pluto has a very large moon called Charon. Charon is very large compared to Pluto's size. It's so large and so close to Pluto that it's actually a binary planetary system. Charon and Pluto actually orbit around each other around a point in space that's between them. And here are some images of the surface of Charon, which were taken by the New Horizons spacecraft on its brief flyby. Alright, so here are the orbits of the planets. And we're going to back away and take a look at how Pluto orbits, and we're going to take a look at the Kuiper belt. So here is Pluto's orbit on the outside, and as you can see, it's different than the orbits of the rest of the planets. Its orbital plane is on a steep incline, and it's highly elliptical. It has a close point to the sun, and it has a far point from the sun. So even though it orbits around the sun just like the other planets, its orbit has a bit of a different shape and a bit of a different direction. After Clyde Tombaugh discovered Pluto, it was the 9th planet, and it remained the furthest object ever discovered in the solar system. Until a few decades later, when we started to discover other objects in the Kuiper belt. So here's a model of the Kuiper belt, and all the objects that orbit within it. A very large zone of objects outside the orbit of Neptune. And the objects in this zone are known as trans-Neptunian objects. And we have since discovered some very large trans-Neptunian objects. We have discovered Eris and Haumea and Makemake and Sedna and others as well. Now you can see that, like Pluto, all of these objects orbit at different inclinations to the Sun, and some of them are highly elliptical. Now if we look at Sedna, which is the green orbit, this object is very elliptical. Look how far from the Sun Sedna orbits, much, much further than Pluto. And its orbit actually extends into another zone of the solar system called the Oort cloud. And the Oort cloud is a sphere of icy objects that surrounds our whole solar system. It's where most comets come from. And it extends out much, much further than Pluto. It actually extends about a third of the way to Alpha Centauri, the closest star system to our solar system. And so as we look at the whole Oort cloud, all the orbits of the planets are almost impossible to see because we're so far out. And now, as we look at the Oort cloud from the outside, we see the three-dimensional positions of the stars around us. And so the Oort cloud is the furthest extent of our solar system. So that concludes our tour of the solar system series. I hope you enjoyed it. Stay tuned for more virtual planetarium shows. Everybody have a great week and clear skies.